Thank you very much. So we've had some very good presentations to lead off and some very big ideas. And so in contrast, this is a small, very specific idea. It boils down to a connector and how a connector can be used to transform a lot of the ways that home area networks and demand response and some future smart grid applications will work. So let's see, how did all this come about? A little bit of history. Late in 2007, I believe, it was the California PUC, after sort of casting about for different ways of making smart thermostats, they call them PCTs, operate and communicate. They made a recommendation, and the recommendation was, well, vendors, why don't you put a port on the side of a thermostat, and that way we don't have to make this decision now. We're going to put a connector on the thermostat, and we recommend you sell thermostats that way, and the industry will figure out how to communicate with them. And that's a pretty simple idea. It is one that has become a pet project of mine, which is why I'm taking the opportunity to speak on it, even though it's a public domain thought. It's a simple idea, and it leads to some big implications. So if you think about it, putting a port on something like a thermostat and having it be exchangeable means, well, it would also be the same port you'd use on a load controller, or on a display, or on a powered hybrid electric vehicle, or many of the applications that we talk about today, and the things that we will collect information for and put into databases and applications in the future. But once you have this common connector, that leads to another interesting thought. This is my modem card that I attached to the side of my computer. It's really pretty neat. The only thing I had to do is sort of plug it in. It's a USB port, and it figured out how to talk to my computer, and it communicates with everybody else in the world. And it's because it's got this little USB port on the end of it. And even if I plug in, let's see, this is an AT&T card, but my Verizon card works in the same port. So start thinking about USB port for utilities. What does that lead you to? Where does that get? Where does that thought end up? And you start thinking in terms of least common denominators. Where is the pinch point? Where is the point in communications and interoperability, exchangeability? I can plug this in different ways. That really makes a lot of difference. So you can do the least amount of work and get the biggest amount of benefit for it. And what the USB port does is it allows you to plug it into different computers, different manufacturers on the one side. If you think about it like a thermostat connector, different thermostats and different loads. And on the other side, there's wholly different communication devices that sit on this side. And yet all these things play together. So these next few slides are in discussion of that. And one of the things that this leads you to is that since you can hang whatever communications device on this side of the port that you want, well, gosh, that communications device can match whatever's in your meter, even if it's a meter you already installed. If it's if it is a smart grid meter, it's going to have code downloadability. It's going to have communications in it already. So why not put that on this end? And then since this will talk to anything that we're going to dream up, thermostats, and other applications in the future, then all of a sudden meters that are even fielded with a code download have the ability to talk to this type of a communications device. So what would that device look like? Well, a favorite application of today, because not only does it represent risk, as we just discussed, meaning it has a load profile that we're not prepared for, but the other side is opportunity in that if done correctly, it can supply energy kind of in a buy-sell sort of a market. So how would a little card be able to help out with that? Well, this point, no. So the place where this connector goes is that little end of that circuit card, and then that end of that circuit board is the USB equivalent. And the little green circuit board you see there, the communications can be anything on the rest of that circuit board, just like this can be various forms of communication. So it could, in this particular example, It communicates to the backhaul, whatever backhaul happens to be in that city. So even though the car might cross country, right, the charging station would have this little connector device, and it would communicate to whatever backhaul the utility had selected. So it allows you to be able to have the flexibility of operation. So that's one application. Demand response programs are better understood. There's more of them out there. But in the last slide here, what I want to address is the demand response programs that are out there, they get kind of limited to 5,000 pilots or 50,000 deployments, or a few of them gotten up to 250,000. So what are things that this connector and the implications of this simple connector, what does it mean for mass adoption? That's the last slide. And then we talk a lot now about distributed generation, and that ultimately all of this achieves a level of energy independence for our country. Again, if you have solar, wind, or others, these are less predictable forms of energy, so to be able to make them really work and do what we want to achieve energy independence, it takes coordination, it takes information. So what is a good way to be able to solve that coordination problem? Well, a card that can plug into all these different vendors' devices on the one side, and on the other side be able to plug into any vendor's communication technology that utility happens to have selected for its purposes. Another aspect in smart grid is energy awareness. I think it's been fairly proven out that as customers have a better understanding of how they utilize energy, that they can make better and better decisions with that. Would this information be useful on the internet? Are there some very grand pieces of back-end software that will exist? Yeah, almost certainly. So there's a couple ways of getting that information back. Well, the meter already communicates back. That's part of what an AMI network does today. On the other side of it, though, with this card, which USNAP, you'll hear why it's called that in a moment, it can plug into a thermostat. This is actually a thermostat that supports the USNAP connector that was born in the California PUC in 2007. But they also sell them with dual ports. So what does that mean? Well, you plug in the other side, whatever is the local home area network. So if it's Zigbee or Zigbee Pro, if it's Wi-Fi, if it's Bluetooth enhanced, if it's one of the many standards out there, then you can plug that in on the other side, and that solves a problem for all of us. It's not a sort of vendor-specific solution. So that allows you to get back on the internet and have another source of information. But it's also a local area network. It allows you to be able to have local control, so it could, in the future, even do things like talk to your PC directly, or to something simple like the energy speedometer. So something that will graphically show what kind of consumption is at the meter on a very updated basis. There's a lot of vision in that area. So at the end, what does all this do? It provides information, and then ultimately it gives users alerts about how to change their behavior in order to be more efficient. So what's another problem this has solved? Well, there is a lot of choices right now. There are a lot of standards that are available in the home area network. There are a lot of products that live on those standards today. And then it is a challenge for a utility to choose which standard is the one that's going to win, which is the beta, which is the VHS. And that creates uncertainty. And the bottom line is uncertainty creates delay. So one of the impacts of having this USB connector of the utility is that it can reduce this uncertainty, because now we know that the meter that you're going to have to buy anyway in an AMI or a smart grid system can be a gateway, a communications port back to any one of these various applications, and again, it can take a second hop and get to whatever standard is being adopted by that home, by that family. If you look at the number of standards that are sitting out there on the left-hand side, and this is a collection of standards over about the last 20 years. I had an X10 a very long time ago. But that is continuing to move up to forms of Zigbee. Most recently, I saw that they were going to make a Wi-Fi Lite version, and they're going to make a Bluetooth enhanced version. There's 6-low-pan. There's a lot of stuff out there. So this would resolve that problem, because it allows these things to be able to still play in the same field through a common connector. So in order to be able to make any business proposition, because this is a business proposition work, everybody in the value chain has to be served. And I'm going to just click and show the three that we've identified. There's the utility, there's the customer, ratepayer, and there's the supply chain, so the folks that would actually sell load controllers, thermostats, smart grid devices. So for the utility, by using this method, they don't add cost to their meter, because the meter already is going to communicate in that physical manner. There is a limit against standards changing, multi-vendor interoperability. So on the utility, a number of strong benefits, faster break even. For the consumer, it does allow a certain level of do-it-yourself. So I didn't have a professional installer. This just plugs into my computer. On the other hand, professional installers are available. That's one of the resistances to mass adoption in demand response programs right now. So to those folks that are green sensitive, it appeals. Energy information, all these things that will be able to be offered as a result, those are all going to give the customer options. And then lastly, in the supply chain, it is difficult for a thermostat manufacturer, I pick on them because they've been trying this for a long time, to pick which standard to use. So they have to make more versions. So this reduces it down to a single version. And so it makes it easier for them to have scale. So if a manufacturer of an end product has scale, what can they do? Well, their prices can probably go down. Vendors, utilities can do RFQs, and which then also helps create the volume. This is open communications. It's actually interoperable, but it's really off of a very, very simple thing. It's called an SPI bus. Almost every microcomputer in the world that you use has an SPI bus on it. So this just attaches some rules around an SPI bus. How you log on, it's got an ID already. It does all the housekeeping for you, and so it discovers what network it's on, and takes a lot less technical knowledge of the user. So last slide here. This is how do you get? This is almost crossing the chasm. How do you move from trials and small deployments to mass adoption and making it easier for all the stakeholders? So how does one sign up for this? In a demand response program, or anyone that has an economic stimulus attached to customer behavior, the utility can send it out with the bill. Say, do you want to participate in this program? So step one, do you want to participate? Step two, customer says, yes, here's some benefits I just read about in my monthly statement. I'm going to save $47. This sounds pretty good to me. Step three, the consumer has two choices. He can go to a local supply store and buy a USNAP compatible device, one that has essentially the utility USB port. But you can also use contractors to be able to provide this. The next is that the consumer receives a pre-configured device. So when the utility would just mail this device, this is too big for the example, but it's received in the mail, and it already has the credentials and the ID. So what the customer has to do is, instead of having to have some fairly sophisticated knowledge in networks, you just snap it into the device. That's how it got part of its name. So it plugs into the device, and it self-discovers. You get a green light, and the device is connected. So again, this is a fairly small idea. It's a little about a 7-cent connector load that would have to go onto products, and talking to an SPI bus that's pretty much in all micros already. And any questions? We can discuss it later.